Hi everyone. Today we'll learn about the full subtractor. So basically in the previous session we know what is the use of adder like half adder, full adder. So half adder used for the 2-bit addition operation and the full adder used for 3-bit addition operation and full subtractor is used for the 3-bit subtraction purpose. So 3 bits I am taking A, B, C is my input, difference and borrow, these two my output. So 3 input is there, so that's why total 8 number of values are assigned here. So when 0 0, so here how to find out the difference and borrow. So is there any difference is there, that time you have to put 1 in the difference. Borrow means if you are taking any borrow from this, then you have to give the value to the borrow. So how to check? So here 0 0 is there, so that's why difference, no difference is there, no borrow is there, so you can check here 0 0 1. So how to find out? 0 minus 0 is known as the 0, 0 minus 0 is known as the 0, and 0 and 1, 0 1 is 1 difference is there, so that's why I put I'm putting 1 here, and 0 minus 1 means it's not possible, so we have to borrow first, so that's why I mentioned 1. You can check 0 minus 1, it's generative and difference is 1, borrow is 1. Then here you can check 0 minus 1, okay, and 1 is twice is there, so that's why there is no difference. Okay, if twice is there, then there is no difference. So 0 minus 1 means it's a taking borrow, it's not possible, so that's why it's taking borrow. So here you can check 1 0 0, 1 0 0 means 1 minus 0 is 0, and 1 difference is there, so that's why borrow is 0 and difference is 1. You can check 111, so 1 minus 1 is 0, 0 1, so that's why difference is 1, 0 minus 1 it's not possible, so that's why here I'm giving borrow is 1. So this is my truth table. So after truth table, this is the expression. So I have converted this expression to the this is the my final expression. Okay, you can check all those things, already I have mentioned the step by step. So these two, first these two, how to find out these two? So for the difference, here 1 is there, so what is the value of 1? You can check here 0 0 1, so that's why A bar B bar C, here 1, so 0 1 0, so A bar B C, then here A B bar C bar, then last is 1 A B C. So after that I convert these two to one part and I have reduced this thing, and also this 2 is the second part. Then here B XOR C, B bar C and BC is known as the XOR, so that's why I'm taking X for the B bar C and BC bar, and here B bar C bar and BC, so that's known as the XOR, so B XOR C. Now remaining A is there, so I mentioned A bar. Okay, A bar is there na, so A bar X, because why X? Because this value is known as the X, and here A, so A, this is known as the B XOR C, so X bar. Now this is known as the XOR A XOR B, so I mentioned A XOR in the place of B. Okay, in the A XOR we find out A XOR, then what is the value of X? Sorry, here not B, it's a X. Okay, so A XOR X, so A XOR, what is the value of X? X value is known as the B XOR C, so here I mentioned B XOR C, same thing I have converted this thing. So this is the like the expression. Now after that we have to design a circuit. So first we'll check what is the circuit. First A XOR B XOR C, so I'm taking this is my software, so I'm designing the circuit. So I change, so remember everything, change all the inputs outputs name. Okay, so now A XOR B XOR C, so first expression is known as the A XOR B XOR C. So A XOR B XOR 3 XOR is not there, so that's why I'm taking 2 XOR A XOR B, and another is the C. So I've connected this output to the this input, and this one should connect to the C. So this is known as the difference. Next, so borrow we have to check. What is the borrow? A bar B XOR C. So first I'm designing, so you can design it, but you have to follow the expression first. Okay, so I'm connected B XOR C, then A bar, so what is my circuit? A bar B XOR C. So first I need the A bar also. So for the A bar I need a NOT gate. So this one is known as A bar. So A bar and with B XOR C. So I need a AND gate. Okay. So A bar B XOR C. A bar B XOR C plus BC. Plus BC. BC is known as a B and C. So I need a AND gate. This one is the B. This one is the C. Just 1 minute. Okay. Then we have to connect these two. These two connect means here plus operation is there. Plus means I need a OR gate. Where is the OR gate? 2 input OR gate. Okay. I'm connecting this one. So this one is the for boron. Okay. So I design my circuit. You have to click on the all option. But now this is the circuit. So you have to check the data. Okay. So we can check this thing 0 0 1 0. So 0 1 0 means 1 1. So we'll check 0 1 0 1 1. Okay. Then 0 1 1. What is the value of 0 1 1? 0 1 1 means difference 0 borrow 1. You can check difference 0 borrow 1. Like that you can check everyone. So here you can check 1 0 0. 1 0 0 means a difference 1 borrow 0. I'll check 1 0 0. So 1 0 0 1 0 0 difference 1 borrow 0. So that's the circuit. You have to design the circuit like this. And how I design this thing, you can use this the expression. So I've already used the expression. You can like that. If you are using K-map also you can easily use, but whatever in the last whatever the expression you are getting, you have to use this expression, and according that you have to design your circuit. So like that whatever I have converted the expression, like that I have designed this circuit. So also, but main motto, we need the output. So thank you for the session.